Hey everybody, in this video, I'm going to talk about using the line of best fit. Well, first of all, calculating the line of best fit using Desmos, as well as using the line of best fit to answer some questions. First problem I am going to answer is shown here, and it is a word problem, so it gives us this entire chunk of text. If you notice, oops, I accidentally there we go. If you notice down here at the bottom, I have two blanks, two things I'm trying to find, a regression equation and the final answer. Now, with that in mind, I'm going to read through this problem. The number of newly reported crime cases in a county in New York State is shown in the accompanying table, where X represents the number of years since 2004 and Y represents the number of new cases. Write a linear regression equation that represents this set of data, rounding all coefficients to the nearest hundredth. And then, using this equation, find the projected number of new cases for 2014, rounded to the nearest whole number. And we have the years since 2004 as our X and the new cases as our Y. Now, you can use their calculator in here, that is great, but I'm going to use Desmos, and I actually have it kind of side by side here, which is actually just a feature in Google. If I hover over this, you can kind of change how you want it to look if you didn't know that. Now, while I certainly can just add an item and add a table and just type in my X and my Y values, that's great. You can copy and paste, and usually it'll work just fine where you copy your first value and select all the way down to the bottom, the last one, and then you Control C, and then you come over to Desmos and you Control V, right? It kind of got what I was trying to do, but you'll notice the values besides the first one all get doubled. So the X's get doubled. The Y's all get doubled. So I just need to reduce it down to what the table truly looks like. And you'll notice I can kind of verify this is true rather quickly because I notice all of these are single digits in the X column, and the Y column, all of them have 4 digits. So this matches. To create the linear regression equation, I am going to add a regression here off to the side to determine, okay, based on this data, what is the equation for the line of best fit? And now that I even have this set up, let's see, I don't know why it's zoomed out like this. Oop. We even have the points kind of graphed and the line in, let's see, I'm going to change the line to be green as well. I just clicked on a little gear up here. So you can see the line of best fit through the data points. Here's just the data points. Here's that linear regression. And it says the equation for this line of best fit is y equals negative 18.4x plus 1077.1. Now remembering the problem asked us to write this regression equation, rounding all coefficients to the nearest hundredth. I don't even need to round here, which is pretty nice. So this is y equals negative 18.4x plus 1077.1. And now this final answer piece is answering the second question. Using this equation, find the projected number of new cases for 2014, rounded to the nearest whole number. And this table is showing us X values as years since 2004. And if we're looking at the year 2014, that is 10 years after 2004. So I'm really looking at when X is 10, using the line of best fit, that equation we just found, what is our predicted Y? So to answer this, I'm going to return to Desmos, and we have this lovely regression equation. I actually have two options. I could either do this visually, and I could find on this green line where X is 10 and what the height is. And one way you can do that too is typing X equals 10 and finding where the red line, which is all the values where X is 10, and the green line intersect. So they intersect when X is 10 on the line of best fit. Y, which remember, Y is the projected new cases, this is 893.1. Now, the way I could do this kind of algebraically, I'm letting X be 10, so using my equation, the number of new cases, or Y, is negative 18.4 times x, which here we're looking at when x is 10 in 2014, plus 1077.1. And I get the same result either way. Now the question again asks for me to round to the nearest whole number for this because we're talking about cases. That's usually a person that has a case of something. We can't have a decimal here. So to the nearest whole number, this would be 893 as my final answer. Let's clear this. 893. All right. Let's try one more. The number of newly reported crime cases now. Wait, it was crime before, wasn't it? I think I turned it into illness. I can't remember. But either way, there are cases in New York. X now is representing number of years since 2012, and Y represents the number of new cases. So let's write another linear regression, and I'm going to just type this one in manually because I think that might be quicker for me. So 0, 1, 2, 3, 4, 5, and then 104, 924, 938, 957, 177, 1023. Beautiful. I don't know which was faster. But, and maybe I shouldn't have clicked the home button. If you click on that little plus sign that was there, notice if I click home, it goes away. But if I click on the little plus sign, and I forgot, I should have done that earlier, it will fit the view so that I can see everything kind of nicely. So here is the data. I need a regression for this, linear regression. So I'm going to add my regression, and writing the linear regression to the nearest hundredth is what we want to round to. So let's see. My coefficients, I'm going to write it off to the side here. I have y equals 22.08571x plus 898.61905. That is the unrounded form. Rounding to the nearest hundredth means I don't want anything 2 digits after the decimal, 2 places after the decimal. So for the number attached to x, this 22.08, what comes after the 8 is a 5, which would cause me to round up to 22.09 or 22 and 9 hundredths times x, plus I have this 898 point, rounding to the nearest hundredth, I don't want anything past the 1, and what comes after the 1 is a 9. So that does round up to 0.62. So my equation here is y equals 22.09x plus 898.62. And this is the line of best fit to represent the data set, the year since 2012 and the crime cases in this county in New York State. Now we want to predict, using this equation, estimate the calendar year in which the number of new cases would reach 1,171. Now, remembering that this is using the line of best fit, if we happen to have a value in the table that matched this, I wouldn't use that. I would use what the line of best fit is doing, which may or may not match that. So predicting which year we are going to reach, there we go, 1,171 cases. Now, cases is a y value. So in this equation, y equals 22.09x plus 898.62. I now want to find x if we're given a y value. So I'm going to let y be 1,000. Oh, what? I'm going to let y be 1,171, and that is equal to 22.09x plus 898.62. 12.62. And now this is an equation where I can solve for x, which I actually could do rather swiftly on Desmos. So I'm going to go over here now, and I'm actually even going to clear off this writing for a moment. I want to predict when y is 1,171. So I'm going to let y equal 1,171 and find where this blue line crosses the line of best fit. So our line of best fit says that after about 12.3329 years from 2012, we will have this number of new cases be exactly 1,171. That's prediction, of course. Now, we're estimating the calendar year, so I would probably just round to the nearest whole year. So I would just add 12 years on to 2012. So that would be final answer 2024. All right. Let's see if it likes it. Yes. Please let me know what questions you have on this. This takes practice, but please keep your X and Y separately. If you are asked to solve, or in this case, the calendar year, I need to find X based on a specific value of Y. And again, it's related to the line of best fit. Oops.